So look at what happens with our h and our k value. H and our k value moves the function, shifts it, picks it up and moves it, keeps exactly the same and just transports it somewhere else. Now that we've looked at that, what do you think will happen if we double our a value? I just want you to have a think. If you're struggling to imagine what that looks like, compare y equals x squared to y equals 2x squared. Okay, what do you reckon is going to happen?
I think the function's going to get like flatter.
Flatter. What do you mean by flatter? Like squashed or
Like the equator's going to go like out more.
out more? Okay. What do you reckon is going to happen?
The opposite of what you said.
Okay, which means what?
It'll get more pointy, go up more.
Okay, very good.
We'd like to be closer.
Well, let's run a test, right? I'm not sure which answer is correct. How can we go about testing this? Jared, start some values in and test it, couldn't we? Okay? So this function here, at x equals 1, what does y equal? This is my original function. It's just this one here. I'll do this one in blue. What is 1 squared?
1.
So when x equals 1, y equals?
1.
When x equals negative 1, y equals? Negative 1 squared is? 1, correct? What does y equal when x equals negative 2? 4. So that's 4 up there, correct? And what about when x equals 2? Same thing?
Yeah.
Now let's graph the function in red for y equals 2x squared. When x equals 1, what will that equal? 1 times 2, which would be 2, correct? When x equals 0, what will y equal? When x equals positive 1? 2? Cool. When x equals 2, what will y equal? 8. So it's going to be like up here, correct? Something like that. So what's happened to my function? Stretch this way, hasn't it? Cool. So what does that a value do? Does it shift our function? Describe what it does. It will. You're explaining this to a year 3 student. Pretty advanced year 3 student, they're doing quadratics. How would you explain it? Use baby numbers, I don't care. It's skinny, so you made it skinnier. Squashed it. I like to think of it as stretching it. Cool? So I've stretched it vertically. If I increase my a value, I stretch it vertically. I'm going to ask you to answer a few other questions now about this a value, because we're going to deal with transformations. If I halve my a value, what will I do? If I halve my a value, finish that sentence off for me. If my a value is negative, I will do what? a day. Teach a man to fish, feed him for a lifetime. I'm not going to give you the answers. You've got something that can help you find the answer. What is that?
Rain.
I don't assume you've all got one of those. What do I assume you've all got? Calculator. How can we check, using our calculator, this new bit of technology, how can we check that? Because back in my day, we used to have calculators that just pumped out black and white images. You lucky millennials, look at you guys, you get coloured functions. So you can set a red function for y equals x squared, and you can set a blue function for y equals 0.5 x squared, for example. You're finding the answers, not me. Ask the calculator. Alright. So, here we go. If I had half my A value, so if my A value is between 1 and 0, for example, what's going to happen to my function? I stretch it horizontally. I like that. I'm just going to write squash it vertically. Because there's a different way to deal with horizontal stuff later. But yeah, you're right. Stretching it horizontally or squashing it vertically, correct? Just how when Jerry said before with the A value increasing, we're squashing it horizontally or stretching it vertically. Cool? I like to think of this A as doing my vertical stretching. If it gets bigger, stretch it higher. If it gets smaller, I squash it. Cool? If my A value is negative, I will split my functions. Around the turning point or the x-axis. Cool? And these are called transformations. So I write this down. When we stretch or rotate our function. Now there is a term that's going to come up far more frequently that I haven't introduced to you yet, and that is the term dilation.